broadcasting is that it can not only offer mobile broadcasting in line-of-sight areas, but also in areas where we have partly blockages, partly shadowing, like in suburban, rural forest environments. So no question that satellite broadcasting on the highway will work. These are not the critical scenarios. The critical scenarios in Europe, where roads are typically much smaller than the US, and where you have more leaves on the trees maybe than in other countries. Also, the critical scenarios can be served with the appropriate technology. The satellite can be used as a feeder link for terrestrial repeaters, for terrestrial gap fillers, for personal gap fillers even. So, for example, small antennas on the roof of the car which translate the DVB-SH signal into a Wi-Fi signal which can be received by an unmodified iPhone. Satellite offers the flexibility of throughput assignment with the respective ERIP the operator wants to spend, and via the used bandwidth which he wants to consume for this satellite transmission. So that's this flexibility can either be translated or both translated be into different types of services, so audio, video, datacast, but also can be used to address different types of receivers, like mobile in-car receivers, portable, or even handheld devices in line of sight, which also is one of the critical corner cases of this DVB-SH system, but which with the appropriate technology, I think we even can serve this thing. There are some weaknesses that all other DVB second generation systems now do offer different quality of service within the same multiplex. This is not included in DVB-SH. This would be required, for example, if we want to serve terminals with very different antenna performances, or with also very different capabilities like screen sizes, power consumption, thinking of application cases like scalable video coding. And also important questions that have to be put on the table is who are the driving forces in this market. So is it the MNOs? Is it the aftermarket? Is it the automotive business? And what is their commitment of these players towards the satellite? Also, as already pointed out, a lot of opportunities in this S-band. There exist in this DVB-SH satellite optimized waveform, which makes the best use of satellite ERIP. So this is, let's say, from technical point of view, in terms of possible applications. We also may think of going one step beyond, of streaming applications, where we could solve the real-time paradigm. Like we're no longer streaming only mobile video like you are used to in digital to home, but also say podcasting or something where it's really file delivery to the receiver, and the receiver just takes from everything he has stored. And you see that more and more terminals are also equipped with storage capabilities. Then the terminal itself automatically, or the user, may pick up content which is already stored on the local hard disk or flash drive or something. Also, the satellite-based broadcasting, it's the ideal backbone for terrestrial services. As has been already pointed out by the speaker before, it will be complemented, and it is designed to be complemented by DVB-H, DVB-SH, both in UHF, in S-band. So I'm one of the person who's really hoping that also DVB-SH in terrestrial gains a lot of success, because then it's clear that creating local terrestrial cells, and for the success of these terrestrial cells, of this system which is based on terrestrial, a satellite component just gives this a real push into the right direction. So also there are some threats which I don't want to dig too much into detail, but basically the main message here is that we should make the best out of the satellite. So from the available bandwidth ERIP that we have, we should try to do the best on satellite, and we should try to do the best on terrestrial. So I don't know, Antonio, do I have still some time on technical details? I have 2 minutes. Okay. So basically, I think I'm trying to skip some slides and just point out that we are believing in this DVB-SH class 2 and TDM approach. So this is one of the main parts of the DVB-SH standard, and this class 2. I don't know whether you're familiar with this acronym, basically hides the concept that a lot of physical layer time interleaving is spent in conjunction with really good physical layer protection. And this class 2 kind of receivers really exploit the satellite to its best, where every dB counts, where every bit per second per hertz counts, and that's the favor of DVB-SH. It really integrates seamlessly with the terrestrial OFDM counterpart, which is undoubtedly extremely useful in deep indoor scenarios, in urban areas, and which is also very useful if you want to serve handheld terminals with a high quality of service. So serving handheld terminals with high quality of service only by satellite is not something which we can aim for. So as a short summary, I tried to emphasize that on commercial exploitation, industrial partnership is a key for this S-band initiative. We hope that we can be one of the key players in this satellite-based broadcasting. The upcoming, already almost on the horizon, upcoming W2A satellite of Solaris offers a lot of opportunities where we think by choosing the right technologies, we can satisfy both quality of service requirement from the user side and throughput requirements from the operator side. And if we do this in the right market environment, we can generate a lot of win-win situations. And the final question is not whether we think that satellite or terrestrial is better. We think that the main question we have to ask on technical side is how can we use satellite and terrestrial at its best flavor each. So thank you very much.